Good morning, everybody. Tremendous turnout this morning. Thank you for joining. We will be recording this morning's webinar, which is across both our US and UK customer base. So thank you, everybody, for joining. Today's topic is an interesting one, really an architecture-led conversation around Oracle architecture modernization and our take on what it means to be running on a modern architecture to achieve highest possible performance levels, agility, operational excellence, ultimately, but doing things in a smarter way, doing things more with less, and ultimately delivering IT to the business faster. That's what today's world is all about in terms of getting through IT quicker and delivering business value. So for those, many of you know Centric already, so we won't go through a big preamble on Centric, but quick intros myself, Abdul Sheikh, CTO here at Centric, one of the co-founders. Been with Centric since the beginning, 19 years now, living in the Oracle world many years, and I'm also joined by my lead architect, Simon Rice. Simon, say hi.
Hey, good morning.
Simon's leading up our enterprise services, delivery of our consulting around our architecture services. So enough about Centric. Really, about topic of the day today is to understand where we're coming from. Many of you have already been through the journey with us in terms of converting legacy traditional architectures onto engineered systems and modern architectures. But ultimately, what it means to be delivering those is also summarized in terms of what we see as the Centric difference. Centric's grown up from being an traditional Oracle partner over the years, building many complex Oracle clustered systems, walking in as architects and bringing together various skill sets and topics within an organization into an optimized architecture conversation. So that's really seen us grow up into Oracle architects, and we offer those optimized architecture solutions to our customer base, both existing and new. Everything we do is delivered around blueprints for risk mitigation to make sure that customers aren't subject to new technology issues, and those deliveries on blueprints are assured and guaranteed from Centric. Ultimately, we all are focused these days on cost, agility, that being hot topics, and ultimately resulting, or the final objective being operational excellence, allowing us all to sleep at night, making sure we're delivering to the business and not fighting fires as traditionally sometimes we tend to do so on traditional architecture. So that's really summarizing what Centric is about. So getting into the challenge of working smarter and doing more with less. Ultimately, we're all being pressured by management, by market pressures, by industry pressures in the various industries verticals that we sit in, to do more with less. That means shrinking IT budgets, exponential data growth, guaranteeing service levels, and meeting compliance and regulation requirements. All of this means we cannot continue to do things in a traditional fashion in terms of spending months and years doing through systems integration of traditional technologies. We cannot be running large sprawling estates where consolidation has not been considered. We cannot be running environments or architectures that are not secure. So all of these hot topics are addressed in today's presentation. I'll get straight into that. But ultimately, this is all about agility, cost management, guaranteeing service levels, and supporting greater business demands and data volume growth. So this is a nice entry point into understanding what we mean by that. So really what we're showing you here is a comparison, a scorecard that we typically provide to customers who are going through architecture assessments with us. And this is how typically a Centric relationship or engagements begins, with a lot of customers running traditional architectures. So when we do a comparison at the exact C-level to deliver that message in terms of what a modern architecture can provide, the benefits are across the board. And we'll provide some of the meat behind this graph in a moment. But ultimately, the kind of scorecarding that we see in terms of the difference in customer experience, both in terms of transactional performance as well as batch performance, our ability to achieve, publish, and meet service levels, our ability to guarantee and meet availability requirements, our ability to exceed and meet data protection requirements, time to recover, data management, agility, scalability, security, and ultimately doing all of this in a less complex manner, and to introduce simplicity across the board is a driving factor as well. And of course, the end result being we need to drive much more business value to the business quicker and faster. So I think what will be interesting for everybody to understand here is how we came up with such a scorecard. When we look at an architecture assessment, we get into many different topics around how a legacy environment or legacy platform may compare to a modern architecture. So effectively, you have to ask yourself, how evolved is my database architecture? Where am I in that journey? Where am I in that architecture roadmap? And the various hot topics, of course, that we talk about beyond the core high availability requirements. We need to make sure our systems are available. Have we embarked on a confident consolidation of our systems? Are we looking at appliance converged-based strategy? Are we looking at cloud? Where am I with my Oracle version roadmap? Am I managing my data effectively? Am I reporting and segregating my transactional data from my reporting and data warehouse data? Have I secured my data? Am I also supporting the productivity of my non-production user base, both developers and users? And ultimately, am I doing this in a smart way to optimize my license footprint? Because we could certainly throw a lot of hardware on a problem like this and ultimately come up with a very expensive bill when we look at our hardware and software costs. We need to do this in a smart fashion. So Simon, we're going to keep this relatively interactive by myself and Simon, but some of the hot topics we see here and some of the reds on the scorecard, maybe you want to talk about that a little bit, Simon.
Sure, absolutely. And yeah, we certainly see some very common pain points across, many of the clients that we initially start to look into their environments. And, as you can see on the left, there are some aspects which on a typical legacy environment are okay. User experience, it may be that users aren't complaining. It may be that users aren't complaining yet. But we are expecting significant business growth or just a natural evolution of our business, and therefore we're expecting user experience to degrade unless we do something about it. So, in user experience and job performance, it may be that things are okay now, but could be a ticking time bomb waiting to bite us there. In terms of data protection is another hot topic. We see many clients out there who are running traditional backups. They take a full backup of their database every day onto their NAS or their SAN. They may never have tested that backup in terms of actual time to recovery. So we've got many clients who, the first time they engage us is after a disaster when they have to restore their production database, and instead of their published SLA of 4 hours, they take 3 days to get it back again because maybe their tapes aren't in the right place, or their backup and restore strategy hasn't been tested. Similarly, around agility, I think lots of people either refresh their test and development databases very sporadically, or they don't do so at all. And then we get into a situation where developers are essentially testing against copies of production that are either very old or are just not representative of production data at all, which then makes a mockery of our test and development cycles, as they are. So, the ability to be more agile in our non-production environments, but also in our production environments, and look at topics such as database as a service, spinning up new environments and new instances in minutes rather than days and weeks is very valuable. Scalability, again, if we are expecting significant business growth, if the business is going to throw IT a curveball and expect us to run with it, how do we cope with that? Because on many architectures, we just don't have the ability to do so. Security as well, the number of clients that we approach that say, sure, we are under HIPAA regulations or we are under PCI. We're not really sure what that means to us. We think we're probably compliant, but we really haven't looked too much into encryption. Maybe our data is encrypted, but our backups and our network traffic are not. We're not sure what to do with user logons, and how do we audit our databases and centralize that audit. Those are hot topics that a lot of companies either haven't considered or are too costly on their current architectures to implement as they are. And data management as well. It's very rare to come across people who are doing sensible things with their data in terms of archiving old data, moving older data onto lower tiers of storage, and essentially keeping their production databases lean and mean and functionally operational and performant. So I'd say in terms of the hot topics that we commonly come across, those are some of the most typical pain points.
Thanks, Simon. So yeah, in addition, when we look at the scorecard, effectively what we're saying is in order to achieve that modern capability, these are the ticks we're looking for in terms of the strategies that we need to employ. And overall, the message of today's webinar is we need to work smarter in terms of managing our transactional databases. We need to be integrating, effectively running a more optimized, dense Oracle platform so we can then leverage the Oracle features and options that make sense to secure our environment and to make our environment optimal. So let's step through the topics effectively. And what we're doing here now, effectively, if you look at the scorecard, the way the webinar is structured today is to just cover off some of the hot topics around those pillars that we address. So really, Simon, you're great at summarizing this. I'll let you talk about this in a moment. But a traditional approach versus a converged approach.
Sure. So, I guess it's funny, I grew up, as many people did in the IT industry, building systems from parts. You buy your server, your HBA, your network cards, and your SAN and your SAN fabric, and you try to integrate all of that together along with the software that runs on that, our firmware, our operating system, our database versions, and our patches. And that was where Cintra, we made our money back in the day, was building and integrating those systems and having proven blueprints for doing so with minimal risk. However, it is very complex, very time-consuming, and as we show on the left, you need multiple resources to do that. You need a DBA, a systems person, a network person, a project manager, and really an entire team to build an architecture which is going to take a number of weeks to deploy. We're bound to hit integration challenges when we go through that roadmap. And at the end of the day, are we going to end up with a system that we're confident is going to run production? Probably not. We're going to need to go through a number of testing cycles to prove that out if it's a new set of hardware. Obviously, the converged approach, and as we show here, it's really the difference between building a car from parts to actually just buying a car from the forecourt and driving away in it. And the converged appliance-based approach is essentially turning on a system which is pre-optimized for your use case, if that's Oracle database, for example, having that highly available out of the box as well, and essentially having a single throat to choke or a single hand to shake when it comes to support, and having all of that managed by a much, much smaller and much more limited skill set that you have in-house.
Thanks, Simon. So many of you have seen this slide before. It's a very common Oracle slide, but really just to summarize, the maturity of engineered systems is now probably in its 6th year. We're getting into that with Oracle Open World around the corner as well. We're expecting this evolution to continue. Our adoption has really started with the Oracle Database Appliance some 4 years ago. We're now close to 250 plus appliances deployed. Exadata has been also a big focus area as well, now we see private cloud appliance and supercluster, as well as Exalogic in the background as well. But really the key message here is Oracle's acquisition of Sun has resulted in a Oracle and Oracle strategy where if you're running a significant Oracle footprint, running it on Oracle hardware means a denser, more consolidated architecture, which means a lower Oracle license footprint, lower costs, and allows you to get on with business and not spend all your time integrating. It's changed the nature of our business. We're addressing many more customers through the door. We're managing many more systems and effectively spending a lot more time on business development and bringing in new customers, not supporting our growth ourselves, but it's effectively accelerating business across the board for our customers and ourselves. So it's certainly been a big success point. We do see competing strategies around B-Block and other converged systems, for example, but they will have certainly the benefits of a converged strategy, but they will not have the benefits of the unique optimizations that Oracle builds into its own hardware. So we'll talk a little bit about that. Many of you are running Exadata. We know some of the names on the registration list today. So we appreciate you already understand the benefits. Some of you, of course, are not. So we'll quickly just summarize some of the benefits. Simon, help me out here in terms of some of the key features within Exadata.
Sure, yeah. I mean, really with Exadata, again, it's a platform which is optimized for a database workload. And, traditionally on Exadata, it was a platform originally designed for warehouse workloads and very specialized for that use case, but more recently has become more universal and has some huge benefits for transactional workloads. But effectively what we do is we offload a lot of our database workload to dedicated storage cells. So there are intelligent storage cells within the Exadata server which know where your data is and provide you with only the data that you need, therefore decreasing the amount of work that the database servers need to do and increasing the speed with which you get that data back. So that's very, very useful when you're looking at large data sets and large scans of data. On the other hand, you also have optimized PCI flashcards in there as well, and Exadata is unique in that it can do both reads and writes from flash. So for transactional databases, you get very, very fast reads and writes as they're written to flashcards rather than spinning disks. So, it's really a combination of those two benefits that we see people get the most bang for their buck. On top of that, we have an optimized network within the Exadata. It uses InfiniBand as its backbone network, and it also has a unique compression algorithm called hybrid columnar compression, which on data which is queried, we see something like an 8 to 12 times compression ratio. On archive data, you could be talking about anything from 40 to 50 times compression there on truly static data. So when you consider the intelligent storage, the flashcards, the unique compression algorithm, which you can only get on Exadata or Oracle storage, and the InfiniBand network internally, it's quite a compelling platform.
So just to follow on from that, Simon, I think the key message there on Exadata is there's so much engineering and unique features built into it. Effectively, we're buying ourselves a lot of headroom, both in terms of compute power, storage power, and network power. That headroom allows us to consolidate confidently, whereas we may have been previously hesitant in consolidating on traditional hardware. Typically, I/O is the bottleneck, and we'll cover that in a moment. But while we look at an architecture strategy, Oracle's maximum available architecture strategy effectively provides us with database redundancy, hardware redundancy, storage redundancy, and site-to-site redundancy. And when we look at that in terms of building a rack cluster or a clustered environment, a lot of the traditional clustering issues, such as the integration complexity, which typically will get us into multi-month deployment timelines, node evictions because of various network issues or storage issues, network contention because of workload management issues between the nodes, and storage contention. All of these things are removed within Exadata because of the unique features within Exadata, and effectively the over-engineering that Oracle has put into the box and to the appliance, which you don't effectively, given what you're buying in terms of hardware, it's comparable in terms of an investment in traditional hardware, but you're getting a lot more for your investment given the unique features within Exadata. So regarding consolidation, this is one of the key pillars within our scorecard that we started with. There's various modes of consolidation. Of course, we see VMware consolidation across the board, but VM in terms of a strategy, both Oracle VM as well as VM, where typically is suited for a small, medium use case that will support databases running on single instances. While running rack on VMware is feasible, the complexity of running clustering on top of virtualization typically is something you want to avoid. So that gets us then into consolidation around dedicated databases and pluggable databases with 12C and 11G features. So Simon, you can talk a little bit about that.
Sure, yeah. So, traditionally we've had the ability to either run, multiple databases on the same hardware or multiple schemas within the same database, and either a schema as a service or a shared server model. That's great, but at the end of the day, your databases run multiple memory structures, they run multiple background processes, and all of those eat up OS resources. So you're kind of limited in terms of the amount of consolidation you can gain from there. As I'm sure most of the people on this call are aware, 12C introduces an option called multi-tenancy, which allows you to have one container database with multiple pluggable databases plugged into it, which not only gives you greater consolidation density because those pluggable databases are all sharing the same single memory structure and single background processes, but there are also benefits there in terms of agility and patching and disaster recovery within there. And really the key message is that by consolidating, it's a fine line between having all of our eggs in one basket and the risk associated there. So certainly we need to architect the platform correctly so that we can be confident that we're consolidating onto a good platform that's going to serve our business. But on the plus side of that consolidation strategy, we end up with a lower software footprint. We can then benefit from greater licensable options that we may not have been able to financially justify on a traditional siloed architecture, and then gives us greater availability, security, compression, and use of those options.
So yeah, just on the consolidation topic, I think the key thing here, Sam, you can talk a little bit about this, where effectively we're saying comparing a traditional consolidation strategy and traditional hardware. And this slide really talks about some of the benefits Exadata brings and how it goes about doing that.
Absolutely. So yeah, really the major benefit when we look at Exadata is because of the I/O capabilities that I mentioned earlier on in terms of the smart storage. When we actually look at how many databases we could run on Exadata versus comparable x86 hardware platforms, by removing the I/O limitations of that x86 platform and running on Exadata, you can roughly look at around a 4 times a greater consolidation density on Exadata, where our databases would become CPU bound before they become I/O bound. And obviously, from the point of view of Oracle software, where we are buying it by CPU core, it's better to be utilizing and maxing out our CPU rather than being tied up on the I/O layer and having our CPUs sitting there idle.
Yeah, if we look at the workload on traditional systems, we will typically find 9 times out of 10 the I/O-bound workload representation, where CPUs typically are lightly utilized. You may see the peak going up by 50%, but most systems are running at 20–30% that we see. I/O is always the bottleneck, going back to the SAN, whether it's iSCSI, NFS, or fiber base attached to a SAN. So what are the key technologies that are going to enable our strategy to a modern architecture? And there's various key topics across today's webinar that we're talking about. We're not only talking about a modern architecture means agility. It means a private cloud strategy. Ultimately, private cloud means you are building an internal on-premise infrastructure that can support many different databases effectively for consolidation. By running a dense consolidated environment, we've effectively built a private cloud platform. That's certainly some of the key topics of the day: private cloud and public cloud and hybrid cloud. And those strategies, certainly Oracle is maturing with its own public cloud this year. We'll see that maturity continue into next year. But really what we're seeing today and most of the trends is a key term, which is putting our house in order. So if you're not already on a consolidation or private cloud strategy, that's something that's to be front and center within your management, some of the key hot topics. We'll be leaving you with today's slides so you can certainly help deliver that message, and we can certainly help you with that as well in terms of help communicate that. And when we talk about these strategies, we're typically selling the message top-down. It's about educating management. It's helping them understand some of these key benefits, not so much coming bottom-up from the bits and bytes and the feature function comparisons between various platforms, but looking at a top-down message from a business value, an ROI, and a financial efficiency model. And ultimately, these products we talk about today, and Simon can drill into this, are supporting these strategies.
Thanks. So, Oracle Database 12c, we're going to talk in a minute about why it's important and how we may get there. But certainly, as I mentioned, multi-tenancy for greater consolidation and greater agility of our platform. There are also other features like automatic data optimization that can facilitate an information lifecycle management policy. And again, we'll cover that off in a second. Enterprise Manager 12c is very important, both in terms of a monitoring and a management tool. It can manage both your on-premise, what we would call a private cloud, but also a public cloud as well in the same view. So you can have a single window into all of your assets, whether they're on-premise or not. You can also use it if you're looking at a database as a service strategy to charge back and show value back to your various business users on their utilization. And there are also, in every release of Enterprise Manager 12c, there are more and more automation and provisioning tools for things like creating clone databases, for leveraging cloning features on things like the ZFS storage appliance. Exadata, we've already talked about the benefits of running Oracle on Oracle and the optimizations that are built in there. In terms of the extreme uptime as well, it's certainly a platform that we recommend for specific use cases there. And the ZFS storage appliance, again, we'll talk about some of these features in more detail in a second, but it provides you with a very fast backup and recovery solution. It provides you with snapshot and cloning capabilities, both for your non-production and also for kind of point-in-time customer service type queries. And it also provides you with an information lifecycle management policy, including compression for archived data as well.
So we've talked about private cloud strategy, and as we see, this is more of a forward-looking topic around how public clouds are going to evolve. Oracle's public cloud is certainly evolving. They're playing a catch-up game when it comes to some of the maturity as compared to Amazon, for example. Amazon's done a very good job in the SMB space when we look at a single instance deployment. Certainly when we look at enterprises, they need clustered deployment supporting technologies like RAC. Oracle will be releasing RAC in the cloud very soon. We're expecting some announcements. Open World and Exadata as a service within the cloud is already there. But as we look at this, effectively Oracle's strategy is to build private cloud and public cloud strategies using the same technologies on-premise and in the cloud, providing portability in terms of moving workloads between those public and private clouds. So that evolution is, I would say, coming in early next year. But it's certainly in terms of how we get there and what strategies we get in place this year to support that is some of the focus areas, the focus topics that we're working on today. So Simon, another key hot topic, of course, is our ticking clock when it comes to Oracle versions. This is probably one of the biggest focus areas in terms of customers' demand for our services and our support this year.
Absolutely, and it's been very common for people to be fairly complacent about the fact that they're running 11G and that there's no need to desperately move on to 12C just yet. That situation is starting to change as we near the end of official support of 11G, and also it's worth mentioning that we saw in terms of 11G versions 11.203 as a very, very stable, very mature version of 11.203. whereas 11.204 introduced some new features from 12c that were kind of backported into 11.204. Things like data redaction that weren't there in 11G previously. There were also some quite significant changes to the Oracle Optimizer in 11.204. So essentially, the risk of upgrading from 11.203 to 11.204 and the requirement for full regression testing and your whole testing of the release itself is just as high as if you were considering 12c. So certainly, 12c should be on everyone's radar, whether you're running 11.203 or 11.204. But if you're running older versions of 11.2, those will be going out of support very, very soon. And rather than getting into the mess of having to pay for extended support, it would be better to look at upgrading to 12c. As we're saying here as well, 12c database has some benefits out of the box. It's more stable, it's more performant, and there's greater functionality in there. We're not just talking about the additional licensable options like multi-tenancy and in-memory database. There are things that are out of the gate built into 12c where you would find a benefit just from a vanilla 11G to 12c upgrade. Particularly if we're talking about 12c rack as well, there are things like application continuity and other benefits built into 12c rack. And you can run 11.203 or 11.204 databases on 12c rack and grid infrastructure. So there's no reason why you couldn't actually be building a new environment or upgrading your grid infrastructure to 12c now to give you a smoother and easier path to 12c database further down the line. The other point here around patching, it's very, very common when we look at an environment that people don't patch often enough and may not patch at all. And certainly patching is time intensive. However, we recommend installing Oracle's patch set updates, PSUs, at least twice a year, at least every 6 months. We normally recommend staying one patch set behind the curve so that we can let other people be on the bleeding edge and experience any new bugs and issues with each patch set before we hit it. However, there may be security reasons particularly why we need to accelerate a patch. But yeah, these patch set updates provide not only security fixes but also functionality fixes to our current code. And we do generally see those as low risk. There's no new functionality introduced there, just fixes over what we're currently running.
It's worth noting that as we move into converged systems such as engineered systems from Oracle, then the requirement for patching is much more stringent, unless we need to be at least 6 months current in terms of our patch levels. Otherwise, we are officially out of support. So patching is much more of a requirement, both in terms of traditional architectures and converged systems going forward. So generally, Oracle, while they look at a quarterly patch schedule, a minimum, sometimes some organizations may see that as too disruptive, but a minimum of 6 monthly patching cycle is something that we are now seeing as a requirement going forward. So when we look at our evolution of our database architecture and how we get onto that modern footprint, ultimately there are various pieces of that puzzle, whether it's a hardware strategy from traditional hardware to appliances and converged systems, operating system, how that's evolving from Red Hat, Oracle Linux, and other flavors of Linux and Windows, to now the predominant version, which is Oracle Linux 6. Oracle Linux is certainly mature, bulletproof, and robust. It's binary compatible with Red Hat, so most things, certainly the topic of the day maybe 3 years ago, where compatibility between Oracle Linux and Red Hat was a common question, that's now more of an assured conversation we're having now, so that's less of an issue. Database, of course, we still see some older databases out there. A lot of our healthcare customers are sometimes have their hands tied around environments that need to be somewhat static for referenceability purposes. But typically we will see 9i, 10G, and 11G, R1 and R2. But of course now there's an aggressive move into being a minimum 11.204 supportable version, and then 12C, of course. Data integration is a key topic as well. We know Oracle's had their previous data integration and replication solutions around streams and advanced replication. Both have challenges, and they are now very much replaced by Goldengate, which is a very robust and reliable tool set. We deploy Goldengate in most of our new deployments, both for replication one way for reporting and data warehouse purposes, data integration and consolidation for various broadcast and consolidation type replication strategies, and now more and more what we call the holy grail of high availability, which is a multi-master, bidirectional, multi-site redundancy strategy that we've implemented for some very large brand name customers who are looking for the highest level of availability to be able to read and write from multiple data centers and have the Goldengate replication keep multiple database instances in sync. So that's certainly a hot topic these days as well. And of course, monitoring is now much more than just diagnostics and tuning pack. It's much more now about measuring our consumption and charging that back and measuring it. So we're going to see that evolve further. And Enterprise Manager 12c brought a lot of new features to the table. We do see, however, when I look at a DBA or database architects or an administrator's workload, it's something that is typically at the bottom of their list. They typically are, we're all busy people, so getting our heads around a lot of new functionality in 12c is an ongoing challenge. But it is definitely now a core product set rather than just a periphery tool set that we should regard it as a key skill set within our capabilities. So Simon, we'll also discuss here how we're doing for time. Pretty good. I think we keep our webinars relatively short, so we'll be running about 45 minutes today, so I think we have about 15 minutes left. So migration is a key consideration. I want to talk a little bit about that as we move into some of the modern versions of Oracle.
Yeah, absolutely. So, every release of Oracle gives us some opportunities for migrating in a different way. And, we've always had things like command line upgrades. We've always had database upgrade assistant around in terms of migrating. And certainly those are useful depending on where what versions you're migrating from and to and what platform. But we also need to look at things like the downtime window, the database size, and the complexity of that database. And, really, we still have old options like export-import, like create table as select. We still have, logical replication options as well, like Oracle Streams is still around in some of the older versions and still supported, as is a logical standby database. Really, our primary tool there would be something like Oracle Goldengate in terms of a logical migration. But if you were to approach us today and ask us, what would be our general recommendation, if we could cherry pick it, we'd be building a clean 12c database and then populating that via a logical migration method. If we have the luxury of time, we'd use something like Oracle Data Pump to import our data. If we can afford a downtime window in order to do that. If we can't, then we look at something like Oracle Goldengate, where we copy our data across in the background from our current legacy database into our 12c environment and then get them in sync. The real benefits there of a clean 12c environment means that we can defragment our data or repack it while we're migrating it, which is not possible during a physical copy. We can also set new features and best practices in 12c before we go live, but also we can use things like flashback database to continuously test our database, flash it back to a point in time, and prove it out. The other point here is that we can, in a fresh database that we're importing into, we can enable things like an information lifecycle management policy that we'll talk about in a second. We can enable encryption and other security features and also varying levels of compression.
I think that's really key is how we make that jump. A lot of us are dealing with large databases that have some extreme uptime requirements. Ultimately, coming back to that key message that if we're consolidated, both in terms of our footprint on hardware as well as licenses, we can leverage some of the features within Oracle that typically sometimes might get too costly to embark on. So ILM, this is a topic certainly, Simon, that we hear about all the time. We're implementing this quite aggressively, but partitioning is key, not only for performance management, but data management as well. So talk a little bit about that.
Yeah, absolutely. So yeah, as you say, partitioning is really the foundation of this. It's kind of phase one of an ILM strategy. The idea is that, in most cases, we segregate data based on date or whatever else our queries are predicated on, and therefore we're reading less data from our storage. Our performance is maintained and consistent as our data volumes grow. With partitioning, you also have the ability to store those partitions in dedicated table spaces which have their own data files behind them. Therefore, our benefits are we can compress those table spaces to a greater degree as that data becomes more static. We can use things like advanced compression within the database. We can also use hybrid columnar compression if we're running on Oracle storage or on Exadata. But also, as that data grows, we can also move data out of our prime real estate of our tier 1 storage and move those data files onto lower tier storage because they're more static and require less I/O. So essentially preserving our tier 1 storage for our most active and our most performant required data.
What's important to understand there as well is that as we archive that data, it doesn't become unavailable. It's still available and accessible across that tier 2 storage, which is the best practice being ZFS storage, which we'll talk about in a moment, a little bit.
And I guess the other point here is that if we do adopt an ILM strategy and we have our most active data on our prime real estate and moving our older static and less critical data to lower storage tiers, what do we do with our unstructured data? I mean, that's great for our relational data, but what about our things like our social media feeds in JSON data types, our images and our videos and our audio files? So really our best practice there is it's now possible, especially within Oracle 12c, to move that unstructured big data onto Hadoop clusters, whether that's commodity hardware or something like the Oracle Big Data Appliance, and actually have a single view through our Oracle database or through other analytical tools of both our relational data within Oracle and our unstructured data within our big data clusters. So it's very important to consider both our relational and our big data there.
This is a topic near to your heart. That's certainly being a Goldengate expert, Simon, but Goldengate is key not only for our data integration, but also for our reporting requirements as well. So let's quickly summarize this one.
Yeah, absolutely. So really, our key goal with real-time reporting is to use something like Oracle Goldengate to do real-time integration of data normally from multiple sources to what we call an operational data store. So essentially our raw dumping ground for that data as it comes out of our transactional systems. We would then use something like Oracle Data Integrator or another ETL or ELT tool to analyze and summarize that data and move that into an enterprise data warehouse or an analytical data store. But the real benefit there, as well as providing a real-time reporting solution and a real-time data warehouse, is that by getting the data out of the transactional databases and into the ODS, into our data store, we keep less of it online in our transactional systems. So we can actually, I guess, strip down the amount of data in our transactional systems, as we're showing here in some examples by clinical trials, for example, archive those out of our transactional systems and move them into our warehouse for querying there. So we can still stay in line with our regulatory requirements to keep data online. We just do that in our operational data store and keep our transactional databases lean and mean.
Okay. Simon, here's an example. Let's quickly describe what we're seeing here.
Absolutely. So over on the left here, this is a data warehouse loading diagram. Over on the left, we have some source systems. We have 5 source databases that are being loaded into a data staging area. And the data staging area is loaded by Goldengate. It's running in real time as transactions are delivered into those source transactional systems. The data is loaded into the staging area. And the staging area is exactly the same. It's identical to the source. So the same schema names, the same table names, the same structures. We then use Oracle Data Integrator. There's actually an orchestration module in Oracle Data Integrator now for ELT to be kicked off as soon as Goldengate has loaded data. So you can actually have real-time data integration from Oracle Data Integrator rather than having to do things like micro batches with your ETL. And we also run Oracle Enterprise Data Quality in order to review and validate the quality of the data as it's loaded into our analytical data store, where we have our star schemas and our fact tables and more, a dimensional model used for our warehouse.
In this case, this is certainly a mission-critical environment, but the customer was one of our SMB, medium-sized customers running the Oracle Database Appliance that we see here as their standard platform. So security, we've got a few more topics to cover, Simon, so let's get into this one.
Yeah, so Oracle have quite a full suite of security products. I don't want to go through all of them now. We certainly don't have time, but some hot topics to just be aware of. In terms of your data security, certainly encryption is very, very key. We've always had the option to do transparent data encryption, whether it's the table space level or the even table and column level. We can now also encrypt user logons via Oracle Wallets. We can also encrypt network traffic and backups as well using the same tools there. In 12c, we also have the option, rather than encrypting data in the database, we can redact that data and mask it from certain users based on profiles as well. The other key point to mention as we're flying through this slide is around auditing. It's very common for people to rely on audit logs within their own databases, which can be compromised by their own database administrators. And certainly if you're under something like HIPAA compliance, Sarbanes-Oxley or PCI, that's not going to cut it. So what we see as a very, very useful tool is Oracle Audit Vault, which enables you to take an audit log not only from your Oracle databases, but also from SQL Server, MySQL, from your operating system logs, and combine those into a single auditing repository, which then has alerts set. So if you have an activity occur which is in violation of HIPAA regulations, for example, you could have an alert come to your compliance or your security officers and let them know that something's gone awry there. And obviously those audit logs are centralized, they're secure, and nobody who shouldn't have access to them does have access to them. So that's certainly a very, very powerful tool.
Okay, thanks, Simon. So another word we've talked about is agility, and what we call zero-cost database cloning. So ZFS is an interesting product. It's a key part of the architecture solutions that we orchestrate because it provides so many different powerful use cases. One of those use cases is database cloning. So while we are sending our level 0 backup on a weekly basis to ZFS as an optimized NFS destination using the direct NFS client with the Oracle client, we are also leveraging that level 0 and daily incremental backup with the ability to use that copy to then create a 0-byte clone in a few minutes, ultimately a scripted process or using the plugins within Enterprise Manager that Oracle provides. That cloning capability is much more powerful than typical traditional SAN-based cloning that we might use on EMC, for example, where BCV backup may use a shadow copy volume. Those are expensive clones because they use actual real estate in terms of storage, whereas the ZFS clone is a 0-byte write-on-copy technology. The only time a storage utilization occurs is when you change a particular clone. So we have customers running 51 terabyte clones every morning. We take about 5 to 10 minutes to spin up those clones, present them via NFS to dev test servers, and that increases productivity tremendously. Another key benefit of that, of course, is the ability to take point-in-time copies of a production database to recover a table or a particular table, data set that may have been inadvertently dropped or deleted, or just troubleshooting a customer issue in terms of operational support as well. So a very powerful feature. But the key message to ZFS is that it provides multiple use cases, which I'll talk about in a moment. And this is just a summary here of the traditional physical clones, either with RMAN backups or with a SAN-based clone, where each clone is taking, for example here, a 35 terabyte data warehouse, which is being cloned n number of times, taking a total of 105 terabytes, whereas on a ZFS clone approach, that's then optimized down to 35 terabytes for just the base image, whereas every new clone is just taking a minimal amount of storage for the change blocks that occurs when a clone is actually utilized. So a very powerful feature. This is an interesting slide, which ultimately what we're looking at here is a comparison of how ZFS as a storage appliance within that modern architecture design compares to a traditional virtual tape device, such as Data Domain, for example, which does a reasonable job when we talk about high-speed backups, but there are certainly challenges when we look at restoration. Support for encryption and compression become challenging within Data Domain. Those are built-in features within ZFS that are then aligned and optimized the actual Oracle compression strategies as well. With Exadata or without Exadata, the use of InfiniBand for high-speed backup and restore gives us a huge number of throughput in terms of our backup capabilities. And the various other use cases through cloning, the ILM strategy that Simon's talked about, and also compression across the board as well. So it's a key part of that modern architecture that we've covered today. So I think we're almost done on time. Simon, this is a good topic for you to finish on.
Yeah, I mean, really, I think this slide speaks for itself. If you look at a traditional way of building an environment on the left here, where we're building an environment based on 8 servers, each with two processors which require 16 licenses. I think as anyone who's built an Oracle architecture knows, Oracle license costs are typically the lion's share of the cost. They make up the majority of our budget when we're building a new Oracle architecture. As you can see over here, building on a couple of servers with small single-core CPUs in this example equates to nearly $600,000 of license costs. If we can consolidate onto a much smaller number of servers, and typically we're able to do so because, as Abdul mentioned earlier, our databases are normally not constrained in terms of CPU, but are much more constrained in terms of I/O. So by consolidating on a couple of servers which require 4 licenses, we reduce our software license cost by 70% down to $150,000, which is obviously very significant. By doing that, what we can do is enable our business to be able to afford more database options, which then all of the databases consolidated onto those platforms can benefit from. So things like advanced security, compression, and so on.
Yeah, that's really key, Simon. I think thanks for that. Also, the COD is a term Oracle has introduced, capacity on demand. This is a feature available on Exadata and the database appliance where in traditional hardware we're required to license all of the cores that are deployed within a particular server or across a cluster, whereas now on the database machines that Oracle provides, the entry-level database appliance or the Exadata machine now have both of the same capabilities, where we can start with a minimal number of cores enabled and then scale that incremental investment as we need it, as the capacity and the business demands. That brings down the initial investment significantly, and then also then allows us to incrementally increase that investment as the business justifies it. So it's certainly a key feature and a huge cost saving as we get into our cost model around engineered systems. So bringing it all together, when we look at ultimately how we proceed from here, some of you may already engage with us on our various service pillars that we're showing here. So our core services are on enterprise architecture services, complemented by our data warehouse, business intelligence, reporting, and application services, and then rounded off by our 24/7 managed services. And of course, cloud as a strategy, both private cloud and public cloud. Many of our customers are engaged with us today in terms of their roadmap and their journey to cloud. So these are all areas we can engage on and help and discuss. So certainly look at reaching out to your existing account manager, or if it's a new relationship, please contact us in terms of how we can assist. But we want to leave you with some of those key messages today. Is we need to be smarter about how we run our transactional databases, keep them lean, keep them optimized, employ that partitioning and data archival strategy, leverage real-time replication over to a data warehouse, and effectively run a more dense consolidated footprint, which allows us to run Oracle database options, moving away from what we call running naked databases. Naked databases is an Oracle environment which is only running the enterprise Oracle version without any of the options. So your data is not secured, it's not managed. Consolidating engineered systems is currently a key strategy. We're looking at thousands of customers now who are running on this. This is a well-adopted strategy that we need to be looking at if you're not already on the Oracle and Oracle roadmap. And of course, ending up in the biggest hot topic, which is already always the case, which is license costs, is always the driving factor here. We need to make that denser ultimately and optimize our license footprint to allow us to leverage some of these things. So thank you. We've taken a bit more time than planned, but hopefully you find this useful today. Please reach out to us, and we'll be happy to have a conversation. And please look out for many more in the sequence of these webinars. Thank you.